So I'm going to show you here what that equation actually means. Y equals mx plus c. So we're going to start with one that we've already looked at. We worked out on the previous video that this line here had the equation y equals 2x plus 3. And we're going to do this the other way round. We're going to start with the equation and then look at how we draw the line on the graph. So we start off with a table. We have x at the top and y beneath it. And I'm going to start off by putting in some values that could possibly be x. Now, this is something you'll get a feel for as you do more of these. But for now, I'm just going to start with 1 up to 5. What we're asking ourselves is, what is y going to be worth? And y is going to be worth whatever we get when we say 2 times by whatever x is, and then add 3. So I've just put that there just so that you can see that when we say 2x, we mean 2 times whatever x is going to be. So if we're saying that x is 1 to start with, I'm going to substitute that. I'm going to put the 1 where the x was, because 1 is now the value of x. 2 times by 1, add 3. Or 2 times 1, that's 2. Add 3, that's 5. So if the value of x is 1, then y will be 5. Let's try the next one. This time x is 2. So we're going to put that 2 in the equation. 2 times 2, that's 4. Add 3, that's 7. So if the value of x is 2, then y will be 7. This time we're going to say x is worth 3. So put the 3 in the equation. 2 times 3, that's 6. 6 add 3, that's 9. So if the value of x is 3, y will be 9. We're not actually going to need the other 2 because the graph doesn't go up that far, but I'm just going to put in the next one just to reinforce how this works. So let's say that x is 4. 2 times 4, that's 8. Add 3, that's 11. So if x is 4, y will be 11. Now here's the graph with the line already on it, just so that you can see where it hits. That first point, we said that x is 1. So if we put 1 on the x-axis, y is 5. So that should hit the line where y equals 5. And sure enough, it does. Let's try the next set of coordinates. If x is 2, then y must be 7. And yes, if we move that up, it hits the line on 7 on the y-axis. If x is 3, it should move up 9 places. And there it is. And you can see that we can't test the 4 across 11 up because the graph doesn't go up that much. And as I said previously, after a while you get a feel for which values you can put in to test x and y. So that line there has the equation y equals 2x plus 3. This one might seem a bit more difficult because you've got a half value in there, but it's not as hard as you might think. This is another one from the previous video where we had y equals a half of x plus 1. And this time we're going to put the points in as we find them. So once again we've got our table, and this time I'm going to start my x values with -2 up to 2. And you'll see as we do this that I could have started with a smaller number and I could have gone on to a much bigger number, but this is just to show you how it works. So once again I'm going to write out what this equation actually means. So we're saying that y is going to be whatever we get when we say a half of whatever x is 1. Remember, if you're timesing something by a half, that's the same as finding a half of that number. So a half times by whatever x is. Well, let's say that x is minus 2. So I'm going to put minus 2 in there. Now a half of minus 2. If you remember the rules for multiplying and dividing with a mixture of negative and positive numbers, where one is a positive and one is a negative, the answer will be negative. If you have a half of 2, that's 1. If you have a half of minus 2, that's minus 1. Now we're going to add on 1. If you have minus 1 and you add on 1, that takes you to 0. So if x is minus 2, y is 0. I'm going to put that point on the graph. So x is minus 2, y is 0, which means that doesn't move, it stays where it is. So there's our first point. Next one, we're going to say that x is minus 1. So put minus 1 in that equation. A half of minus 1 plus 1. Well, a half of 1 is a half, so a half of minus 1 is minus a half. And if we add on 1, if you have minus a half and you add 1, that takes you to a half. So if x is minus 1, y is a half. We're going to put that point on the graph. X is minus 1, y is a half. So that will go up halfway between 0 and 1. Next one, x is 0. A half of 0, well, anything you multiply by a 0 is 0. And then we're going to add 1. If you have nothing and you add 1, you've got 1. So if x is 0, y is 1. We're going to put that point onto the graph. X is 0 and y moves up 1. Next one. This time x is 1. A half of 1 is a half. Plus 1 is 1 and a half. So if x is 1, y is 1 and a half. Put those coordinates in. X is 1, y is 1 and a half. And last one, we're saying that x is 2. A half of 2 is 1, and 1 and 1 is 2. So if x is 2, y is 2. X is 2, and 2 up. And you can see we can start drawing our line here. So if I start where those points are, you can see where the line goes up. So I could have carried on a bit further. You can see that if I take the line back, I could have started with something like minus 4. But either way, you can see where that line is. And the equation of that line is y equals a half of x plus 1. And a quick reminder that the half represents the gradient, the m, that's in the y equals mx plus c. And the gradient is how steep the line is. And in this case, the gradient is a half, because it goes up a half each time it goes across from one point to the next. And that the 1 represents the c in y equals mx plus c. And that's where the line passes through the y-intercept. If you found this video helpful, please click the thumbs up button and subscribe to my channel.